Hello, good morning, good afternoon, good evening, everyone. Welcome to this masterclass session on mathematics conducted by the Institute of Actuaries of India. Before we get into it, a quick introduction. My name is Kevin Rajiv Punamia. I am a qualified actuary of the Institute of Actuaries of India and a qualified chartered accountant. I have been working as an actuary for the last 5 years, majorly in consultancies, and I am a passionate teacher. So I've been teaching actuarial science subjects to students at a private coaching institute for 5 years as well. And today's session is to get you guys acquainted with mathematics of your ACET examination. So let's get into it. I'll give an introduction about ACET, about your different subjects, and then we will try and cover the curriculum for mathematics. Okay. So yes, ACET, I hope you guys are aware if you're thinking whether or not to start your actuarial journey. I would strongly suggest ACET is a great way to do that, because that way you will understand the different concepts that surround actuarial science, and it's a great test to see whether you like it or not. Okay, so you have ACET 2026 coming up, more on that later. Yes, today's session covers mathematics by me, Kevin Punamia, and if you are aware, there are a total of 4 subjects or 4 areas in your ACET, that is Actuarial Common Entrance test, which is mathematics, statistics, data interpretation, and logical reasoning. We are going to cover mathematics in today's session. The idea is I will not be covering the entire curriculum because that would be unfair for a masterclass. Rather, I will try to show the extent of your syllabus, of the types of questions and the types of areas that they ask over. It's usually 11th and 12th mathematics. And I will show you 3 different levels of questions that they can ask, which is easy, medium, and the difficult questions, so that you can accordingly understand and judge for yourself how the exam is suited for you, and so that you get an idea of the type of questions and the type of content we cover here. Okay. So on that note, let's start with, of course, the easy ones, the simple questions. All of these are past exam questions. Just to give you the idea, I will cover 4 questions of simple, 4 medium level questions, and 4 difficult level questions. In each of the question, I will explain the concept, I will explain the solution, and we'll get to the solution. And I will try my best to explain how you guys should think while you're in the exam. Okay. So let's start with the first one. Okay, so this is from the previous examination. And as you can see, this is a question on vectors. That is, vector p equals 3 hat minus 2 j hat, and vector q is 4 I hat plus 5 j hat, and you have to find the scalar product of vector p dot vector q. Okay, so this is the dot product of your vectors. I'll just quickly write it down. So this is how you solve it. Vector p equals 3 minus 2, so 3 I hat minus 2 j hat, and vector q is of course 4 I hat plus 5 j hat. Now, if you are aware of the dot rule, you can directly apply and get the answer. And if you're just trying to recollect, maybe 11, maybe 12 was a little time ago or something, then just for your reference, I hat, j hat, these are all unit vectors. And the properties was something like this, that is I hat into I hat will always be 1 because these are unit vectors, and I hat into j hat will always be 0. The reason was that whenever you multiply 2 vectors, so any 2 vectors when you multiply to b vector, that will be, the answer will be mod of a times the value of b into the cos theta between them, right? So if you have the vectors which are the same, so they'll have the same direction, this will be multiplied by cos of 0, which is of course 1, and when you multiply 2 other separate unit vectors, they are orthogonal in nature, that is, they are perpendicular to each other, and that is why you will always have cos of pi by 2 or 90 degrees, and that is always 0. Correct? So you can just directly apply this formula, or you can just use and solve using first principles. So here I'll for now just try and show you using first principles how this can be done. So this is 3i hat minus 2j hat times 4i hat plus 5j hat. Correct? And in vectors, when you're using the scalar product, you can apply the what we call as the distributive property. That is, simply you can apply your normal algebra of doing it something like 3i bar dot 4i bar and minus 2j bar dot 4i hat plus 3i hat into 5j hat minus 2j hat into 5j hat. Correct? So as you can see from what we have on this right side here, that is, for separate unit vectors, the product is going to be 0, which is why we can just directly go on and eliminate these two over here, which is 2j into 4i and 3i into 5j. And what we'll be left with is 3 times 4 here and minus 2 times 5 here. So if I just go on and solve that portion, I'll get 3 into 4, and over here I can get minus 2 into 5, which if you can just directly solve, that's 12 minus 10, which is 2. So you can just go on into your question and see that is option A. So I'll just write here your answer will be A. So this is how you can solve some of these sums, which is just applying the basic rule, basic principle, and you should be able to solve it. As I said, I have used the longer route to show you the concept. In exam, you don't need to do this. Just you understood that, okay, this is where we apply the dot rule. What is the dot rule? Dot rule is simply where you have, let's say, xi hat plus yj hat, and you are multiplying this with, let's say, zi hat plus kj hat. So you just need to multiply the component forms. So the component form of I is x into z plus component form of j is y into k, and that's it. That's your answer. So in this case, as an exam student, what I'll do is I'll simply say, okay, 3i, 4i, 3 times 4, that's 12, and minus 2j into plus 5. So minus 2 into 5, that is minus 10. So 10 minus 2, that is option A, and that is the correct answer. Okay. So if you remember this, I'm pretty sure you would be very happy by now, because this was quite manageable. You didn't need to think a lot with this. And with that, then let's take that momentum and that happiness into the next question. So I'll just quickly go to the second question. So this is on trigonometry. Again, a very widely covered area in your ACET. The principal value of arc sine of negative root 3 by 2 is. Okay. So what is arc sine? If you have heard this terminology, that's great. Otherwise, I'll just quickly tell you. Arc sine of a value, let's say y, is nothing but sine inverse of that value. And if you remember what is sine inverse, then the logic is something like that. If x is sine inverse of y, then therefore what we are saying is sine of x is actually y. Correct? So for example, I'm sure you are aware that sine of 0 is 0, or for that matter, sine of pi by 2. This is in terms of radians. Pi by 2 is nothing but 90 degrees, right? So sine of pi by 2 is 1. So this implies that sine inverse of 0 is 0, or that sine inverse of pi by 2, rather sine inverse of 1 is pi by 2. And that is the exact logic we have to apply over here as well. And as I said, sine inverse is nothing but arc sine. So this is then nothing but arc sine of 0 and this is arc sine of 1. So the arc that is being made by this particular value of the sine. Correct? So hopefully you remember this and you understood this concept. If yes, then let's go on to our question. So we have to find the arc sine of negative root 3 by 2. So essentially, if I say theta is the arc sine of negative square root of 3 by 2, then what I'm saying is that sine theta should be negative square root of 3 by 2. Correct? Now, if you are aware of the table of theta, then or of sine theta, then the answer should be something like this. So I'll quickly give you the idea. Theta at 0, sine theta is 0. At pi by 6, that is 30 degrees, this is half. At pi by 4, that is 45 degrees, this is square root of 2 upon 2, or you can say this is 1 upon under root 2. At pi by 3, this value is square root of 3 by 2. And at pi by 2, which is 90 degrees, this value is 1. A very nice way to remember this sine table is simply, you have 0, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Just write 0, 1, 2, 3 and 4. Take a square root of this numerator and divided it by 2. So this way, the first one is obviously 0. The second one is square root of 1, that's 1 by 2. Second one is square root of 2 by 2. So you can just write it like this, square root of 2 by 2. This is square root of 3 by 2. And square root of 4, that's 2 by 2, which is 1. So that is an easy way to remember the sine table if you don't. So okay, we have found out that okay, for square root of 3 by 2, I have pi by 3. But that's not the answer, right? Because we want negative root 3 by 2. So if you remember the property of sine, that is sine of negative theta is actually negative sine theta. So this is true for sine because sine is an odd function. It oscillates up and down, and it's, if you remember the third and fourth quadrants, it is negative. So negative theta is in the third and fourth quadrant, that is from 180 to 360 degrees, and that's when it is negative. And that is why here we will say that sine of negative pi by 3 is actually negative sine of pi by 3, which is negative square root of 3 by 2. So with this, we kind of get our answer that okay, this means therefore theta is actually negative pi by 3. And with that, we can see that the option B is the correct answer. First is plus pi by 3, so it's kind of confusing. There is a good chance that in the flow of the exam you will just look at root 3 by 2 and you will realize, oh yes, I remember that is pi by 3, and you'll mark option A. So just take a moment there, try to read the question and see, okay, there is a negative here, and always read the other options. So this is my key suggestion in an MCQ exam is, if you feel that you found the right answer, still have a look at the other options carefully, because there may be a twist in the question which you not have realized, and which may actually be, you may be able to understand that by looking at some of the other option. For example, here I will see pi by 3 and in my fast mind I may want to just go ahead with it, but as I look at the other options, pi by 6 where, but then I say, oh, negative pi by 3. So then I may start questioning that is it positive pi by 3 or negative pi by 3, and then I go down the route of okay, sine is an odd function, which means the negative theta is negative sine theta, and that's why it's b. If it was cosine, just to give you the idea, if it was cos of negative theta is cos theta. So there it would still be plus pi by 3, correct? So with this we get here our answer is option B. I hope you all understood this, and I hope this is a good revision to your trigonometry. If everyone is clear with this, then I'll go now to the next one. Okay, so it says the domain of the function f of x, which is square root of log of x square minus 2024 is, and you have these three options. Okay, so how do I find domain of a function? Domain of a function means the output should be a real number. So I want to find square root of log of x square minus 2024, and I want to find the domain of this. So for this to be a real number, what I want the condition is, because it is a square root, if I take a square root of a negative number, that will lead to an imaginary number, right? It's not a real number. So here I want the condition that the inside part of the square root should be positive. So that is condition is log of x square minus 2024 should be greater than 0. Okay, so log of this should be greater than 0. I have to remove this log now somehow. So what can I do? So I can just exponentiate both the sides. So if I just, when I say exponentiate, I'm just saying I'll use e raised to that particular number, both sides. That is e raised to log of x square minus 2024, and it should be greater than e raised to 0. So e raised to and log cancel off each other, and on the left side you have x square minus 2024, and this should be greater than 1. So this is the key concept in the question. You may be very excited to say that okay, log of this number is greater than 0, so that's why the inside part of the log should be greater than 0. But that is not the case. Log of any decimal between 0 to 1 is a negative number, right? So log of every number greater than 1 is positive. Log from 0 to 1 is negative, and log of 0 is not defined. Log of negative numbers is not defined. So I want x square minus 2024 should be greater than 1, and now I can easily solve this, that therefore x square should be greater than 2025. So this minus goes over here, this becomes 2025, which means if I just take the square root, now square root could be a positive or a negative. Therefore, what I want is mod of x should be greater than square root of this. Square root of this is 45. So mod of x should be greater than 45, which means that x should be greater than 45 or negative x should be less than negative 45, correct? So that's the domain. If I just show you on a number line, so kind of like this, you have negative infinity, then you have, let's say, negative 45, 0 somewhere around here, 45, and then you have positive infinity. This is your number line. So what we are saying is the domain should be this region plus this region. That is, the region in between should be ignored. And let's see which of the answer fits this definition. So if you just go here, you can see negative infinity under root 2024, under root 2024. So I can just tell you this square root 2024 is a very smart option, because as I said, you think that okay, I want something to be positive, and you may just want the inside part to be positive, which will lead you to the answer that x is greater than square root of 2024, correct? Because you may skip this 1. So that is exactly what we don't want to do. And you can see now the option C, which is negative infinity to minus 45 and union. So union means including both. So it's an OR type function. Union with 45 to positive infinity. And that is why option C is your correct answer. So I'll just write here answer is option C. Correct? I hope this was intuitive. I'll repeat here for the sake of people that you don't need to write all the steps in exam. It's an MCQ exam. I'm here to explain you the steps, the concept behind it. That's why I write it. But in the exam, as soon as you realize that, okay, square root of log of something, just have the capacity and the sharpness to think that, okay, we have to make this greater than 0 because it's square root, which means you have to take the log, which should be greater than 1. And then it will lead you to this option C. Clear, everyone? So now with this, we finally move to the fourth question of the simple category, that is the simple questions. And the fourth question is something like this. So this is a question on AP. So you go a little more back, that is to your 8, 9, 10 standard, and that's why you might have seen this. So it says there is an arithmetic progression where A202 is 4, A4 is 202, then A2024 equals what? And you have 4 options. Okay, so AP, quickly giving you guys the formulas. I hope you remember AN, AP, arithmetic progression, that is you have a series of numbers which have a common difference, right? So an example of an AP is something like 3, 5, 7, 9, 11 and so on. And in this AP, I will say that A1 is 3. A is your starting number essentially. So A or A1 is 3. D, that is the difference, is a 2 plus 2 because you have a difference of 2 continuously, right? And the notation was, let's say this is the fourth number in the AP. So this is called as A4 or T4 in some cases, right? So here I'll just say that AN, the formula for AN is always A plus N minus 1 into D. That is the first number plus the number of intervals between the final number and first number. So as you can see, if I take the example of A4, then how many intervals do we have between A4 and A1? That is 3 intervals, 3 to 5, 5 to 7, 7 to 9, correct? So similarly, AN is always A plus the number of intervals N minus 1 into the difference D. And with this, then we can try and find that for the given AP, what is A and what is D. So A202 is given as 4 and A4 is given as 202. So we can form two equations based on this, that is A plus N minus 1, that is 201D is equals to 4, and A plus 4 minus 1, that's 3D is equals to 202, correct? Now if I just subtract the second equation from the first, so minus, 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 the A's get cancelled. Here you have 198D is equals to, and this is minus 202 plus 4, so that is minus 198, and therefore you can solve that D is negative 1, correct? So again I'll repeat the approach. I formulated two equations based on this formula, A plus N minus 1D. I solved them simultaneously and I got D as minus 1. If I just substitute this in, let's say, the second equation, then I get, therefore, A plus 3 into minus 1 is 202, and therefore A is, so this becomes negative 3, it goes on the other side, this becomes 205. So your A, that is your first number, is 205. Just to give you the visualization, your AP is actually something like this: 205, 204, 203 and so on. The 202nd term is 4, right? This is the 202nd term, A202 and so on, correct? So that's the AP. Now we need just the final answer, that is we want to find out A2024. So A2024 using the same formula will be A plus 2023D, that's 205 plus 2023 into minus 1. So essentially you want to calculate 205 minus 2023, and using some extraordinary calculations in my mind, I can calculate this is minus 1818. Okay, you don't even need to do this calculation because you have this option over here and you can just confirm with it. But since you do have none of the above option as well, it's just better to cross check that, okay, whether the calculation is correct or not. So here your answer is option A. And with that, we are very happily done with the easy part of the questions, and we can now try to take it up a notch. But just before that, a quick shout out or a quick point to note about ACET. ACET is the Actuarial Common Entrance test. It is conducted by the Institute of Actuaries of India, which is a worldly renowned institute of actuarial science exams. There are very few actuaries, as you may already be aware if you're seeing this masterclass, and ACET is your sort of first entry, first step into the overall actuarial sort of domain. Exam is beautifully structured. It's kind of similar to your other entrance tests. That is, it tests your cognitive ability by checking maths, stats, data interpretation, and logical reasoning. It's a complete MCQ based objective exam, so there is no subjectivity involved, no confusion involved. You either know it or you don't know it. The current exam or the next exam will be conducted on 10th January 2026. So you still have a good amount of time to sort of cover up your concepts. While the registration closes right after Christmas, that is on 26th December till 6 p.m. you can enroll yourself into the examination, right? So even if you want to enroll from this, you can just scan and register at this point, right? Why ACET? So ACET, as I said, is like the first step to actuarial science, and I hope you have your answer of why actuarial science. I mean, I can go on and on about why actuarial science. It is one of the most globally recognized profession because the skills we learn are mathematics, finance, tech oriented, and these are something that is not confined to India or to, let's say, a state in India or something like that. These are global skills. What I learn here is applicable for all the countries across the world, and that's why it's a very global opportunity. It's very future oriented because even the calculations we do on a day-to-day basis are future oriented, and we use a lot of data, we use a lot of computational power, and going forward we are going to be using a lot of AI as well. That is why it's one of the highly skilled, highly paid profession as well. So they are in huge demand, as you can see, and it's an emerging field in India for sure. I don't have the very recent statistic, but the total number of qualified actuaries in India from the IAI are close to 550 or 600, something like that. So just that small number. If I just compare this with the number of CAs we have in India, I think it is about 3.2, 3.3 lakhs CAs that we have in India. So you can see the amount of growth that is still there. Okay. So yes, that's all about ACET. I hope that you enjoyed the easy part of the question so far, and that you are ready and excited to move to the next part. So now let's continue with the medium level questions that you may see in your exam. So starting with this one. So it says the interval in which fx is x raised to 4 minus 4x cube plus 5 is strictly increasing in x is, and then you have 4 options. Okay. So we are given a function and we want to find the interval where this function is increasing. Okay. How do you find whether a function is increasing or decreasing or anything else, right? So f of x is x raised to 4 minus 4x cube plus 5, correct? How do you find whether a function is increasing, decreasing, or has a break or anything? So if I just show you, let's say visually, let's say we have a function that is something like this versus let's say a function that is something like this. So as you can see, the first function till this point, you can just mark this point here, till this point you can see the function is increasing, and after this it kind of flattens, and let's assume that from this particular point it just continuously decreases. In our second example, you can see that over here maybe somewhere till this point you see the function is decreasing, and after this there is a change in direction and the function starts increasing. How do you find that which are those points, or where does the function actually start increasing, decreasing? So the mathematical way to find out whether a function is increasing or not is to find out whether differentiation of the function is greater than 0 or not. So if the differentiation is greater than 0, you can say that the function is increasing. Why? Because if you understand what is differentiation, differentiation is the difference between the function's two values, two very close values. So let's say you will have x1 as 10 and maybe x2 as 10.0001, something like this. You are trying to differentiate. So what differentiation calculates is, I will calculate f at x1. So f x1, which will be f of 10. So when I input 10 in this equation, what is the value? And f of x2, that is f of 10.0001. The idea is, if the function is increasing, that is this particular thing is actually nothing but in a way f of x2 minus f of x1 upon x2 minus x1. Correct? So differential values of fx upon differentiating values of x. So f of x2 minus f of x1 upon x2 minus x1. And the idea is, we know x2 minus x1 is positive because x2 is greater than x1. That's how we have defined it. It is positive. In our case, it's 0.0001, x2 minus x1. So now, if this is an increasing function, we want f of x2 to be greater than f of x1. Correct? In increasing function, we want f of x2 to be greater than f of x1, which means we want f of x2 minus f of x1 to be greater than 0. So what we understand is the denominator is positive, it is greater than 0, because that's how we define it. The numerator, we want the numerator to also be greater than 0 in order to this be an increasing function, which means both numerator and denominator should be greater than 0, and therefore the ratio of two positive numbers will always be positive. So that is why we want numerator and denominator positive, which gives us to this particular outcome, that differentiation of f of x upon dx should be greater than 0. And that is how you actually identify whether a function is increasing or not. Similarly, if somebody would have asked me that whether this function is decreasing, then you can just apply the same logic. For a decreasing function, I want f of x2 to be less than f of x1. So the second value should be less than the first one, which means f of x2 minus f of x1 should be less than 0. And if you want the numerator to be less than 0 and the denominator is a positive number, so negative upon positive, your answer will be a negative number. And that means for a decreasing, the proof is that its differentiation should be less than 0 for decreasing. Correct? This is for decreasing. This is for increasing function. And you may just be curious of, okay, what if the value is exactly 0? That is f of x2 and f of x1 is the same. I hope you remember that when the differentiation of f of x is actually 0, at whatever point this happens, this point of where f of x2 and f of x1 is the same, this point is called as the maxima or minima. So this is just additional information that the points where it is 0, it is either the maximum value of the function or the minimum value of function. Why is it the maximum value? Because you can see that the function increases, then after this point it decreases, which means at this particular point you will ideally see that f dash x, which is nothing but d of fx, is 0. And same way here you will see that f dash x is 0. Both of these are 0, however, this particular point is the maxima, this is the minima. And if you remember, how do you find whether the point is maxima or minima? So you had to do the second derivation. So the second derivation, d2fx upon dx square, if that is a negative number, that means your original point was maximum. And if the second differentiation is positive, then your original point was a minima, correct? So we entered into a separate territory, but the question could very well be on a maxima minima, so I just wanted to explain this. But for now, we will continue with the current sum, which is f of x. We want to find the range over which this is increasing. So all I need to do is I need to differentiate this, and the differentiation should be greater than 0. So differentiation of this is x raised to 4. So I hope you remember that differentiation of x raised to n by dx is n into x raised to n minus 1, correct? So that is 4 into x raised to 4 minus 1, that is the first one, and the second is minus 4 into again 3 into x raised to 3 minus 1. And then you have plus 5. Differentiation of a constant is always 0. So plus 0. So therefore we get the differentiation of this as 4x cube minus 4 times 3, that's 12 x square. And this value should be greater than 0. For it to be an increasing function, this value should be greater than 0. I can just simplify, I can divide both the sides by x square, and with that I get therefore 4x minus 12 is greater than 0 upon x square is 0 only. Therefore 4x is greater than 12, and therefore you get your final answer, x is greater than 3. So x is greater than 3. We can just go back to the question and see if there is any option, and you can see the option C, which is 3 till infinity, is your correct option and your correct answer. So that is why we will say that here the answer is option C, correct? So I hope the concept we learnt on this question will help you to find increasing, decreasing functions, minima and maxima, all those things, correct? So that was your first question. Let's move to the second one in the medium category. So this is an interesting one. It says find the coefficient of x cube in the binomial expansion of 2x minus 1 by x the whole raised to 7. Okay, what is binomial expansion? Like, that's the first question you may have. So let's quickly see the formula for binomial expansion. So I'll just give you a very basic example. So let's say if you want to do x plus 2 raised to 3. So the binomial expansion says that this will be summation of I going from say 0 to 3, because we have cubes, so 0 to 3, of 3ci into the first value, which is x raised to 3 minus I, into the second value, which is 2 raised to I. So what do I mean by that? Let's quickly see. So if I open this up, this becomes something. This is the formula for binomial expansion. I will write the general form later as well, but this is just to show you what the formula does. So in the component form, this formula looks like 3c0. This is from combinations, right? So 3c0 into x cube into 2 raised to 0 plus 3c1 into x square into 2 raised to 1 plus 3c2 into x into 2 square, and finally you have plus 3c3 into x raised to 0, 2 raised to 3. So if I just simplify this, 3c0 and 3c3, these are 1. So this first value is x cube. 3c1 is just 3 upon 1. So that's 3. So that's 3 into 2 x square plus 3c2 is also 3. So 3 into 4, that is 12x, and 3c3 is 1, x raised to 0 is 1. This is just 2 cube, that's 8. So you can simplify this, x cube plus 6x square plus 12x plus 8. In fact, you can apply the a plus b whole cube formula and you will get the same answer, correct? So this is the binomial expansion, and if I just write now the generic form, that is a plus b raised to n should always be summation from 0 to n of nci a raised to n minus I and b raised to I, correct? So this is kind of like the probability function of your binomial distribution. That is why the name binomial expansion. That is NCI, and you just add all the possible values over here, correct? If I just write this in the component form, you will get something like NC0 a raised to n b raised to 0 plus NC1 a raised to n minus 1 into b plus NC2 a raised to n minus 2 into b square, so on till the final value, which is NCn a raised to 0 b raised to n. So this is the general form of the binomial expansion, okay? So I hope everyone is clear with the overall binomial expansion formula, and now let's look at our particular case and try to apply this. So the question is 2x minus 1 by x raised to 7. So you have 2x minus 1 by x raised to 7. So if I just compare, your a is 2x, your b is minus 1 by x, because the general form is a plus b. So here you will say b is minus 1 by x and n is 7. Okay. And the question is very interesting. It's not asking you to solve this entirely, of course not. It is just asking you to find the coefficient of x cube. So how will you find a coefficient of x cube? Now you will be very inclined to just directly go to the third term, NC3 term or something like that. But be careful, here you have 2x and 1 upon x. So every time there will be an x in the denominator which will be cancelling out the numerator somehow. So if I just try to write down the general form, so 7c0, 2x raised to 7, and obviously minus 1 by x raised to 0. That's the first one. Plus 7c1, 2x raised to 6, minus 1 by x raised to 1. correct? I hope you understand here. We are not calculating it for now, but just to give you the idea, here you will have x raised to 6 into 1 upon x. So here, whatever answer you get, this will be coefficient of x raised to 5, correct? Because you will have x raised to 6 in the numerator upon x, that is x in the denominator, and it will cancel out to x raised to 5. And then if you calculate the numeric part of it, you will get its coefficient. Okay, so that's how you have to think. Plus 7c2 2x raised to 5 into minus 1 by x square. So again, this will be, if you understand, x raised to 5 in the numerator, x square in the denominator. So this will be coefficient of x cube. So is the answer over here directly? The answer is yes, because if you find the others, just to give you the idea, the next one will be numerator x raised to 4, denominator x cube, that will be x cube upon x raised to 4, that will be x raised to minus 1, x square upon x raised to 5, that will be x raised to minus 3, and the final one, which will be x raised to 1 upon x raised to 6, that is x raised to minus 5. And apologies, this will be the final one, that is 1 upon x raised to 7. So this will be x raised to minus 7. So as you can see, the coefficient goes something like this: x raised to 7, x raised to 5, x cube, x raised to minus 1, x raised to minus 3, x raised to minus 5, x raised to minus 7. Correct? We are interested in the coefficient of x cube. So this term will simplify and give us the coefficient of x cube. And that will be 7c2 into 2x raised to 5 into minus 1 upon x square. So 7c2 is 7 into 6 upon 2 into 1 into 2x raised to 5. So that is 2 raised to 5 into x raised to 5 and minus 1 by x square. So the minus gets cancelled out and this will be 1 by x square. So if I simplify the number part, this is 42 by 2, that is 21. 2 raised to 5 is 32. 2, 4, 8, 16, 32. So 21 into 32 and this will be x cube. So as you can see, this part is the coefficient of x cube. And if I solve this, 32 into 21, you can use your calculators of course, but the answer should be 640 plus 32, that is 672 x cube. So 672 will be your coefficient of x cube. So using this binomial expansion, we see whether 672 is one of the option. The answer is option D. And that's how you can get that, okay, the answer for this particular one was option D. I hope this was clear with everyone. You just need to know the formula for binomial expansion and then have the awareness that over here you have a numerator x and a denominator x which will cancel out each other. After that, as I said, you don't need to do a lot of calculations. It looks overwhelming, but you just need to find out that, okay, x cube, you isolate it and then just solve for that. And that you can say is 672 x cube. So hope that is clear with everyone. And with this, we move to the third question. So this is an interesting one. Matrices is something that always interested me. So it says, which of the following matrix operations is undefined, given that matrix A has dimensions 3 by 2, B has dimensions 2 by 4, and C has dimensions 3 by 4. Okay. So it's multiple choice question where you have to actually look at the options to identify which is the correct one. You won't be able to solve for it directly, right? You have to look at the options and understand which one is fine, which is not fine. So I hope you guys remember the rule about matrices. That is, I'll show those rules. So let's say if you have a matrix that is, let's say, m by n, and if you have another matrix B that is, let's say, n by L. Okay, these are the dimensions. M is the rows, n is the columns. First one is the row, second one is the number of columns. Okay, so to multiply, if you want to multiply two matrices, right? The multiplication of two matrices, it's a matrix multiplication. You need to ensure that column of first matrix has same dimensions as row of the second matrix. So what do I mean by that? In this case, if I want to A into B, can I do that? So column of first, which is n, and rows of second, which is also n, this is the same, and A into B is definitely a valid multiplication. That is, you will be able to find the answer. And in fact, I hope you remember this, that your final outcome, let's say the outcome is C. You will multiply this, you will get another matrix C. C will be a matrix of dimensions m by L. So you will get an m into L matrix, correct? So just to give you an example, if A was, let's say, 6 by 5 and B was, let's say, 5 by 8. So 6 rows, 5 columns, 5 rows, 8 columns. Can we do A into B? The answer is yes. And whatever answer we get C, that will be a 6 by 8 matrix. 6 rows, 8 columns. Correct? That's the rule about matrix multiplication. So on that, if I now ask you that whether B into A is possible, the answer is no. B into A is not possible. And this is kind of the unique thing about matrix, right? In numbers, we don't think like this. If 4 into 5 is 20, we just know that, okay, 5 into 4 is also 20. But in matrices, I said that is absolutely not the case. B into A, in fact, is not possible at all, because B has, in my example, n by L, and this one has m by n. The column of the first, which is L, should be equal to rows of the second, which is m. So L is obviously not equal to m, and therefore this is not possible. Just like in this example, if I want to do B by A, here the columns are 8, the rows of the second one are 6, and you will not be able to multiply this. Correct? So hope everyone is clear with this. Another rule is, if you want to add two matrices, A plus B, the simple idea is both should have same dimensions. So this is very simple. Both should have exactly same rows, same columns. Otherwise you cannot add, right? Both should have the same dimensions. So same rows, same columns, only then you will be able to add two matrices. So if you want to add, it should be the same. If you want to multiply, then I explained you this rule. Based on this, now let's try and apply the logic over here. And maybe just before that, I'll quickly speak about transpose of a matrix. So you might have heard this while studying matrix. Transpose of matrix A. So what is transpose? So there is an entire calculation of coefficient matrix and all of that, adjacent matrix, which you can do to find. But the idea is, if A is an m by n matrix, then its transpose is denoted by AT, and that is always n by m matrix. So in simple terms, the number of rows and columns will interchange. That is, if A is a 3 by 4 matrix, then A transpose will always be a 4 by 3 matrix. So it's as straightforward as that. Correct? You don't need to know how to calculate this for this particular sum. So there are these entire minus coefficient matrix and all of that that you can calculate. But for now, we don't need to do all of this. All we need to do is find out which of this is undefined. Okay. So the first one is A into B plus C. So I'll just quickly write here all the options, and I'll write what A, B and C are. So A is 3 by 2, B is 2 by 4, and C is 3 by 4. Okay. So the first one, A into B plus C. First of all, can A into B, is it possible? So A is 3 by 2, B is 2 by 4, 2, 2, that is the product is possible. Very good. And in fact, whatever the output is here, the output will be a 3 by 4 matrix. So you will have a matrix, let's call it X, which is 3 by 4, and you have to add C to it. C is also 3 by 4. So 3 by 4, 3 by 4, can you add them? Yes. So this is definitely valid. So the first matrix is certainly possible. Let's look at the second one. The second one says A transpose into C. So A transpose into C. A is a 3 by 2 matrix. As I said, its transpose will be a 2 by 3 matrix. So A transpose will be 2 by 3. And you are multiplying this with C, which is a 3 by 4. So 2 by 3 into 3 by 4. Is it possible? Yes. 3 gets matched. And this is definitely possible. I decided the outcome will be a 2 by 4 matrix. Correct? So this is also possible. Let's look at the third option now. C into A. Is C into A possible? C is a 3 by 4 matrix and A is a 3 by 2 matrix. So here, number of columns of C are 4, number of rows of A is 3, and this is definitely not possible. Not possible. Okay. So the answer is option C. Just for completeness, we can also look at option D, whether that is possible. So you have B transpose into A transpose. So B transpose into A transpose. B transpose will be 4 by 2. A transpose will be 2 by 3. So this will be 4 by 2 and this will be 2 by 3. So this is also very much possible. Your output will be a 4 by 3 matrix. Correct? So as you see that here the option, the correct answer will be answer C. Okay. So this is another type of question wherein you don't have to necessarily solve the question, but you have to actually look from the options which is the correct answer, right? And if you know the basic rules of matrices, then this is something that should be possible. Okay. So with that, we are now finally there to the last question of the medium category, which is again a trigonometry and a calculus combined question. Good one. So it says limit theta tends to pi by 4 cos of 2 theta upon cos theta minus sin theta. Okay. So limit theta tends to pi by 4 of cos of 2 theta upon cos theta minus sin theta, right? So before doing any simplifications, you should just see whether the denominator is 0. So whether this is a 0 by 0 type of limit. So you can just apply that cos of pi by 4 minus sin of pi by 4. Now sine table I had given earlier, if you remember. So sine 0, pi by 6, pi by 4, pi by 3 and pi by 2. So I had given this table and I had explained you the logic as well of how you can find this. So this was 0, half, under root 2 by 2, under root 3 by 2 and 1. Correct? A very nice trick to remember the cos table, that is cos theta, is it is simply the opposite of sin theta in this table. So that is, here we went from 0 to 1, cos theta will start from 1, then under root 3 by 2, then under root 2 by 2, then half and then 0. So this is a very nice way to create sine and cos tables using the simplified formulas. And if you know the basic trigonometry formulas, now you can easily find tan theta, cot theta, cosine theta, cosec theta, correct? Because those are just reciprocals or ratios of these. But yes, in our current case, we find that at pi by 4, both sine theta and cos theta are under root 2 by 2, which means this will be 0. So here your denominator will be 0, which means you cannot substitute theta as pi by 4 at the current stage. Okay. So that means you have to now simplify. So how will we simplify this? So we have to simplify cos of 2 theta upon cos theta minus sine theta. So there is not much to simplify in the denominator, but there is definitely something we can do with the numerator. So if you understand cos of 2 theta, can I say that can be written as theta plus theta, correct? If you are aware of formulas of trigonometry, cos of A plus B, if you are adding two angles, cos of A plus B, there is a formula for this, which is cos of A cos of B minus sine of A sine of B. Okay. So this is a formula in trigonometry. You can just go back and cross verify as well. That is cos of A plus B is cos A cos B minus sine A sine B. I would advise you learn the same formula for sine as well. Okay, it's not very different than this. So cos A cos B minus sine A sine B. Let's apply it in our cos 2 theta. So that will be cos of theta plus theta is actually cos theta into cos theta minus sine theta into sine theta. Can I say this simplifies to cos square theta minus sine square theta, correct? So you have cos square minus sine square theta in the numerator. Your denominator was, so cos square theta minus sine square theta upon cos theta minus sine theta. So this was your denominator. Now this is where the math brain starts functioning, that how do I simplify this further? And here you should remember that as a child you had learnt a formula that a square minus b square is always equal to a plus b into a minus b. Why is this important here? Because when I apply this formula, I will get here cos theta plus sine theta into cos theta minus sine theta, and that is the same as the denominator. So I can then cancel out the numerator and denominator. So let's do this. This is cos theta plus sine theta into cos theta minus sine theta upon cos theta minus sine theta. So this gets cancelled and you are left with limit theta tending to pi by 4 of cos theta plus sine theta. And now there is no problem in us substituting the value of theta. So this becomes cos of pi by 4 plus sine of pi by 4. We have the table above to get us these values, that this is under root 2 by 2 plus under root 2 by 2, which is under root 2. Do we have an option that is something like this? Yes, option D is exactly this. So we can then say that answer is option D. So I hope you guys understood the medium level difficulty questions. The medium level difficult questions are absolutely not like difficult to think or judge. They are just difficult in the sense that you have to understand a formula, that a formula is applicable here, and then apply it, right? So if you are aware with your content, then this is something that should be manageable. And of course, with this, we now move on to the most awaited category of the day, which is difficult questions. Yes, and now we finally move to the difficult questions. So quite an interesting thing ahead. I can assure you that the difficult questions are not difficult by the sake of like the nature of the question or something. The questions are still intuitive. You just have to apply some formulas, think about which formula will apply, and you just need to have a vast knowledge base. So that's where, you know, the real difficult questions come from. Without further ado, we can start with the first one. So you have to use the Newton-Raphson method to estimate root of the equation. Fx is x cube minus 2x minus 5 equals 0. So we are given a function and we have to estimate root of the equation. You can start with an initial guess of x0 as 2 and you have to then calculate x1 and x2, rounding your answers to 4 decimal places. Okay. So one thing is obvious over here, that you need to know the Newton-Raphson method. If you know it, then applying it is quite straightforward. If you don't know it, then it's very difficult. It's going to be very difficult for you to guess the answer here, right? There's no logical way to do it. So we have to understand the Newton-Raphson method, and that's why I'll just briefly explain you what it is. Newton-Raphson, obviously these are two names of scientists who came up with this method. And what they're trying to do is, in many cases, okay, like a quadratic equation, can we find the roots of those equations? Yes, you have a lot of ways, like the formula method. It will work on any quadratic equation and give you the roots. But if there are more difficult, more transcendental equations where you cannot find roots using some ordinary method. Okay, so if there is a complicated function, like it's a complicated f of x, like the current case, and you want to find the roots of the equation. I hope you know roots means the values of x where the equation will hold true, correct? So you have to find roots of the equation. It's a complicated fx and you want to find roots of the equation. So what Newton-Raphson said is, you can do one thing. I'll just explain you the logic behind it. You don't need to know this, but just for your understanding, I can just help you. So first plot your function. Let's say this is the function, whatever f of x, you can just plot it. Start with an initial guess. So let's say this could be a random number, but you have to try and guess with a logical number so that you'll get the answer quicker. If it's a very abnormal guess, a very abnormal starting point, then you may struggle a lot with this method. So we start with a logical guess for where the equation may hold true. So like in this case, it's a cubic equation, x cube minus 2x minus 5. And they are saying you can start with the initial guess of 2. So you can start with the initial guess of 2. Now the idea is plot the point of the function on this particular value, right? So this point would be, if you understand, x0 and f of x0. So something like that. So this is the point you will plot, and the geometry behind this is, now you want to create a tangent to this one. So like create a tangent, which is there should only be one touching point. And the idea is, wherever this tangent meets the x-axis, wherever it meets the x-axis, that should be your next guess. So this is an iterative process. After x0, I will get x1. So I'll just try to find, okay, what is the value of this function at this particular point. So at x1, what is the value that I will find? This is x1, f of x1. And again, I will try to draw a tangent to this one, right? And based on this, mine is a very hypothetical one, and that's why the tangents are too far away. But based on this, the idea is you will find x0, then x1, then x2, and so on. And there will come a point wherein, let's say you have found, for example, x45. It does not take this long. Just giving you an example. You find x45 is a particular value. And based on this, then you find x46, which is very, very close to x45, right? So the difference is lower than the tolerance level which you can determine. So they are very, very close. And that's when you have to stop and say that, okay, this is the final root of the equation. So that is a value which will be called as a root of the equation. So this is the geometric understanding of Newton-Raphson method. Now, obviously, we will not sit and create these tangent lines ourselves. What we will do is use mathematics to actually find the values x1, x2, and so on, right? So this x1 point can actually be found by the Newton-Raphson formula, which says, the general formula is that xn plus 1 will always be equal to xn minus f of xn upon f dash xn. Correct? So xn plus 1, that is your next guess or next guess for the root, will always be your initial guess or your starting guess minus the value of the function at that point upon the differentiation of the function at that point, right? At the initial guess. And this is how you can find and keep on finding the xn plus 1, n plus 2 and those values. Correct? So from exam perspective, this is all you need to know. That is the formula for Newton-Raphson, and that should be it, right? This entire background I just gave so that you understand exactly what you're applying and you're not just blindly going into it. But from an exam perspective, again, I'll repeat, all you need to do is this. So in our case, we are given x0 and we have to find x1 and x2, okay? So let's first find fx and f dash x. So fx is given, fx is x cube minus 2x minus 5, correct? F dash x, that is the first differentiation, will be x raised to n is n into x raised to n minus 1. So this becomes 3x square and this becomes minus 2. Phi is a constant. The differentiation is 0. Correct? So we have 3x square minus 2. This is the differentiation of f dash x. Now we want to find x1. So x1 will obviously be equal to xn plus 1 is xn. So x0 plus, or rather minus, f of x0 upon f dash x0. So what is x0? x0 is 2 minus f of x0. So in this equation of fx, use 2 and this becomes 2 cube minus 2 into 2 minus 5 upon, in the f dash, that is the differentiation, you have to use again 2. So that is 3 into 2 square minus 2. And this becomes 2 minus, this is 2 cube 8, 8 minus 4 minus 5. So this is minus 1 upon, the denominator is 2 square, that is 4 into 3, 12, minus 2, 10. So 2 minus minus 1 by 10, and that is simply 2 plus 1 by 10, which is 2.1. So x1 is 2.1. They have asked us to do it till 4 decimals. So it's 2.1000. Exam tip, at this point you can actually stop and go ahead with answer D, because that's the only one with 2.1000 as the answer, correct? But for now, we want to double confirm and we want to ensure that our x2 is something like this. So we just move ahead and try to find the value of x2, which will be x1 minus f at x1 upon f dash at x1, correct? So just applying this, 2.1 minus same thing, 2.1 cube minus 2 into 2.1 minus 5 upon 3 into 2.1 square minus 2. And if you do this on your calculator, you should get the answer 2.0946. So no surprises, x2 is 2.0946, which means x1, x2 is 2.1, 2.0946, which should be option D. So with this, you get your answer as option D. I hope this was clear. The Newton-Raphson method is again one of the frequently asked ones. So you should just remember the formula, then applying it should be cakewalk. Okay. So I hope everyone understood this. That was your question 1 of the difficult series. So far, hopefully so good. And with that, we move to the next one. That is, you have to find out value of this particular integral. Minus 2 to 5, integrating to minus 2 to 5 of mod of x minus 1 dx. So mod of x minus 1. If there was no mod here, this would have been a simple question. But the mod kind of adds some complexity. So let's try and understand what it is saying, how will we solve it, correct? So first of all, what is mod of any number? Mod of x, what is it? So it is just the positive value of this number, right? So it's just like the number without any magnitude. So it's just x without any sign basically. So it's just the magnitude, sorry, not the sign. So it's without any sign. It's not plus minus, it's just the value itself. For example, mod of 5 is obviously 5. Mod of minus 3 is 3. So minus 3 says that it's 3 on the negative side. The mod says we just are concerned with the value that is 3. Okay. So in simple terms, mod of any number should always be greater than 0. That's the main condition, that mod of the number should be greater than 0. It cannot be negative because a negative simplifies to a positive. Correct? So I hope everyone is first of all clear with this. Now let's try and evaluate this integration. So the integration is from minus 2 to 5. So if you just want to visualize it, it's kind of like this. That you have minus 2 here and you have plus 5 here. And your function is mod of x minus 1. So for example, at 5, the value has to be 4. Correct? Because 5 minus 1, that's 4. And that will be the value of the function. Okay, similarly at 4, it has to be 3. At 3, this has to be 2. Similarly at 2, this value should be 1. It should be a linear equation because the degree of the polynomial is 1. So it's a linear equation. And finally at 1, you will see that the value is 0. Correct? Because 1 minus 1, that's 0. So the mod of that is 0. But what happens at 0? So if I take x as 0, the equation becomes mod of 0 minus 1, which becomes a minus 1. Now we cannot have a minus 1. So what we need to do is we need to just have 1 as the outcome. So instead of at 0, instead of doing mod of 0 minus 1, like this will obviously be minus 1 ka mod, which is 1. To do this without using mods, what we can say is after at 0, we need to ideally reverse the sign. So this will be mod of or rather we can just say this is equation of 1 minus x. Instead of x minus 1, we will say this is 1 minus x. So before this was simply the value of x minus 1. And after 0 or after point 1, where you reach 0, the equation kind of will reverse and you are essentially giving the values of 1 minus x, right? So at 0, this will be 1. So it will be kind of an increasing line after this. So this will be the function, if you understand, that is at 1, it converges to 0. And you can just identify this, that if I want mod of x minus 1, so which is the value where I have to start reversing the signs. So if this is equal to 0, you can say that x is equals to 1. X is equals to 1 is the point from which you have to start reversing the sign. So the idea is from minus 2 to 1, you are essentially integrating 1 minus x. And from 1 to 5, you are integrating x minus 1. Because this ensures that the mod is accounted for and that you are only having positive values. Correct? So it's as simple as that. Essentially all you want is if x is less than 1, obviously 1 minus x will be positive. If x is greater than 1, then x minus 1 will be positive. So once you have identified this, now how do we go about our integration? So we are trying to find the integration of minus 2 to 5 of mod of x minus 1 dx. And we have identified that between this range, this equation does turn negative, right? So that's the point where we have to start splitting or changing it. So you can actually split this integration into two parts, wherein your first range will be minus 2 to 1 and the second range will be 1 to 5. So you can always split the limits of integration into two integrations. So I'm integrating minus 2 to 1 and 1 to 5. To integrate between minus 2 and 1, I will obviously have the function as 1 minus x dx. And from 1 to 5, the same function is x minus 1 dx. So this is a core concept, that is, because of mod, I cannot have negatives. To avoid negatives, I have to reverse this equation because that's the positive value, and that is 1 minus x below 1 and x minus 1 above 1. Once you get this, now doing this is straightforward. That is, you just need to apply the rules of integration carefully. So it's x minus x square by 2. So the integration of x is x raised to, or rather I'll just write the formula. Integration of x raised to n dx is always x raised to n plus 1 upon n plus 1. And very nice way to remember is always that differentiation of the answer will give you this question of the integration. So if I differentiate this, I should get x raised to n, correct? So here we have x minus x square by 2 going over the range 1 to minus 2, plus this is x square by 2 minus x over the range 1 to 5. Now all you need to do is apply the limits and see what the answer is. So this is 1 minus 1 by 2 minus 2 and minus 4 by 2, correct? This is the first integral, and then the second one, which is 25 by 2, that's 5 square minus 5, and this will be minus 1 by 2 minus 1, correct? So you can just simplify this. This is half, and this will be minus 4, so that will be minus 4 and half, so this will be 4.5, plus this is 25 by 2 minus 5, that's 7.5. 7.5 minus of half, so you just add half over here, so that's 8. And you can just do this in calculator and you will get your answer as 12.5. So 12.5 is the final answer. You can look at it in the integral and you see option A is 12.5. So your answer here is simply option A. Correct. So hopefully that was also manageable. The mod, whenever the mod comes, all you need to do is ensure that the function is positive. Then you can apply the normal integration rules. That's it. Correct. So that was question 2. With that, we now move to the question 3 of the difficult section, which is evaluate limit x tends to 0, e raised to 20x minus e raised to 24x upon sin x. So this is a complicated limits question. Now I say complicated, if you know the formulas of limits, like if you've studied it recently, you remember those formulas, this should be a cakewalk. You just need to do one adjustment and you're done. In the chance that you've done limits a little time ago or you don't really recall it, you can do this using some first principle formula, but then you need to just remember the first principle formula, right? That's the L'Hopital rule. So I'll show you using the L'Hopital rule, and I'll also make the reference that if you knew the formula, just how straightforward that would be. Okay. So we want to find limit x tends to 0 of e raised to 20x minus e raised to 24x upon sin x. Now, if I just apply the limits 0, you can see the numerator is 1 minus 1 because e raised to 0 minus e raised to 0. So that is 0 upon sine of 0, which is also a 0. So this is a 0 by 0 form of a limit. Correct? So what you can do here is, if you remember some of the formulas. So if you know the formulas, let me just advise those here. That is, if you remember some of these formulas, which is, limit x tends to 0, x upon sine of x, I know this is 0, I know this is 1, and also limit x tends to 0 of e raised to kx minus 1 upon x. I know this is supposed to be k. So if you know these formulas, then what you can do, you can apply this first way of doing it, which is you can say this limit x tends to 0 e raised to 20x minus e raised to 24x upon sine of x can be written as limit x tends to 0 multiplying and dividing by x. So that's e raised to 20x minus e raised to 24x upon x into limit x tends to 0 x upon sine of x. Okay. So this second part of the equation is sorted. We know the property limiting x by sine x is actually 1. So this becomes 1. And then all you need to do is work with this first part. Now you can just see that, okay, I know the formula e raised to kx minus 1 upon x is k. There is no minus 1 element here, but can I include that? And the answer is yes. What you can do is you can simply subtract and add 1 over here. So you can just do e raised to 20x minus 1 plus 1 minus e raised to 24x, the whole upon x. And what you can do now is just split this into 2. So you have limit x tends to 0 e raised to 20x minus 1 upon x, and take minus outside. So minus limit x tends to 0, and because you have taken minus outside, e raised to 24x is now positive, 1 is now negative upon x. So now you have two equations in the form which you are aware of, e raised to kx minus 1 upon x, which is k. And this is obviously 20, this is 24, and you will directly get your answer minus 4. Correct? So if you know the formula, you do it like this and you get your answer as minus 4, which is option D over here. So I can just write here, answer is option D. Okay. But as I said, what if you don't remember this formula, right? You remember another version of this formula or anything can happen. You don't know how to split this. In that case, can we solve this sum? The answer is yes. Using a very interesting rule, which is the L'Hopital rule. So you might have seen this in your college. That is the L'Hopital rule. And what it says is whenever you have a limit of the form 0 by 0 or infinity by infinity, right? A 0 by 0 or infinity by infinity limit, if you have that, then the idea is using some approximation. This guy found a very nice and neat formula. And the formula is something like this, that if you are doing limit of f of x upon g of x, so these are the two functions which are both turning into 0. This will be the same as the limit between f dash x upon g dash x. So when you are very close to 0 by 0 or infinity by infinity, what the L'Hopital rule says is you can just take the differentiation at this point and take the ratio of those two differentiation. Because you are at the very extreme, the ratio of the function and ratio of the differentiation is the same approximately. That's what the L'Hopital rule says. That at the edges, that is 0 by 0 or infinity by infinity, the ratio of the functions is the same as ratio of the derivatives. And this is of course if f dash x and g dash x exists. That's obviously the case. If they don't exist, if the differentiation is not possible, if it's 0, then obviously this does not apply. But if they do exist, then you can just take the ratio of that and apply the limits. So can we do it in our current case? Let's see. So we have limit x tends to 0 of e raised to 20x minus e raised to 24x upon sine of x. So is it a 0 by 0 type limit? You can just let's check. If I input 0 over here, this becomes e raised to 0, which is 1, minus e raised to 0, which is 1. So the numerator is 0, and upon sine of x, which is sine of 0, which is 0. So numerator and denominator both are 0. So I just said this is a 0 by 0 type. Correct? Which means I can apply this rule over here, that is, this limits is the same as limit x tends to 0, and I have to take differentiation of the numerator upon differentiation of the denominator. So differentiation of the numerator, I hope you know this, that differentiating e raised to ax by dx is simply a into e raised to ax. That is it, right? So this simply becomes 20 into e raised to 20x minus, again the same thing, 24 into e raised to 24x upon differentiation of sine of x. So I hope you remember, differentiating sine of x is nothing but cos of x. Simple as that. So that is cos of x. And now can I apply the limit? So first of all, the differentiation exists. Great. Now can I apply the limit? The answer is yes. So now this is 20 e raised to 0 minus 24 e raised to 0 upon cos of 0. So the numerator is minus 4 and the denominator cos of 0 is 1. So this is minus 4, which is obviously your answer. So in fact, you get this answer even quicker, because here you had to do all the massaging and manipulation. In the second approach, that is the L'Hopital rule, you just identify it as a 0 by 0, take the differentiation, input the limit. That is it. So answer is obviously D, which is minus 4. And these were the two ways in which you can find that answer. Both, obviously, the exam does not care about your method. All it cares about is that you get the final answer. Correct? So that was your third question in the difficult category. And we happily move to the last question for the day, which is a geometric progression AI is such that A20 is 25 and A25 is 20. Okay. Let k be the smallest integer greater than 25 such that ak is an integer. And then you are asked k plus ak equals. Okay. So logically this is not very difficult, but you have to apply a lot of things to actually get to the final answer. And that is why this is in the difficult category. So you have to apply a geometric progression. So we did a sum on arithmetic progression earlier. I hope everyone is aware of GPs. So GPs, geometric progression, how APs are series of numbers with equal differences. GPs are a series of numbers with the same ratio between them. So for example, a very simple GP would be 3, 6, 12, 24, 48, 96 and so on. So what is happening here? You start from 3 and you're just multiplying this with 2. Again, you multiply this with 2, multiply this with 2 and so on. So that is how the ratio 2, this is basically the notation for 2 is R in this case. So R is the ratio and the starting value is always important. So A is 3 in this case. And again the same nomenclature, this is A1, A2, A3 and so on. So one of the well-known formulas for GP is that AN is always equal to A into R raised to n minus 1. Correct? So just like how it was A plus n minus 1d earlier, here it is multiplying, so it's a ratio, and raised to n minus 1, because the second value you're just multiplying with 2 once. For the third value, you're multiplying the first number with the square of 2, because you're multiplying 2 twice and so on. That's the simple logic. Correct? So AN is A into R raised to n minus 1. So with this, now let's first try and find out A and R of the current series. So you're given A20 is 25 and A25 is 20. So this means that A into R raised to 19 is 25. A into R raised to 24 is 20. So what you can do, let's say this is equation 2, this is equation 1. You can say 2 divided by 1 will give you this divided by this. So A gets cancelled. R raised to 24 upon R raised to 19 is 20 upon 25. Therefore, R raised to 5, solving the LHS, is 20 upon 25, or you can just say 4 upon 5, which is nothing but 0.8. So, R raised to 5 is 0.8 and you can solve. Therefore, R is 0.8 raised to 1 by 5. Correct? So, 0.8 raised to 1 by 5, that is the fifth root of 0.8 is your common ratio R. You don't need to solve it in like the decimals. 0.8 raised to 1 by 5 is the R, and you can just put this in any of these equations to get the value of A as well. But I would say that is not very important. Why? Because A25 is 20. Okay. Without A, can I still find A26? Yes, that will simply be 20 into 0.8 raised to 1 by 5. Okay, then can I find A27? Yes, that will be 20 into 0.8 raised to 2 by 5 because I'll multiply the same value twice. Similarly, what is A28? That's 20 times 0.8 raised to 3 by 5. A29 will be 20 times 0.8 raised to 4 by 5. And finally, A30 will be 20 into 0.8 raised to 5 by 5. So the idea was 0.8 raised to 1 by 5, 2 by 5, 3 by 5, 4 by 5. All of these will lead to irrational numbers. What is the question? The question says, let k be smallest integer greater than 25. So we have found A25. So after this, which is the smallest integer, where ak is an integer. So we want ak to be an integer, and as you can see, 26, 27, 28, 29, 30. A30 is the one where if I solve this further, I get 20 into 0.8, which is 16. So A30 is that number where you get the value as an integer, and this is then the answer that we want, that is k is equals to 30. But don't jump to the answer because they are asking you have to find k plus ak equals to what. So k plus ak is 30 plus 16, and that's 46. So you can just find that option B is the correct answer here. So you can say then, okay, answer is option B. So I hope everyone understood this. That is the geometric progression, finding out R, knowing in the exam that you don't need to find A. You can find A, it's very easy, but there is no reason for you to do that because the question is simply asking you to find the smallest integer where ak is an integer. And to do that, you just need to find the subsequent values of the GP, realize that okay, A30 is the one where the next integer lies, and that's your final answer. Okay. So congratulations everyone, you've completed this mathematics masterclass for ACET. If you were able to solve all these 12 sums, then I am very sure you should be able to easily ace the ACET. And as I said, like, don't wait, just secure your spot. The registration closes on 26 December. You have the exam on 10 January. So all the very best. Do enroll, do give the exam, and I hope to see you soon in the actuarial circle. It's a very small circle. So I hope to see you at some point. Okay. So that was me, Kevin Punamia, and I hope you have a very good rest of the year. Thank you.